Welcome to the deep dive. Today, we're looking up, way up, at something really quite extraordinary that just launched. It promises to change, well, fundamentally change how we see our own planet.
It really does.
I mean, imagine this for a second. What if we could give Earth a pair of all-seeing eyes? You know, watching every tiny tremor, every shift in the ground, every subtle change, day and night, rain or shine.
It sounds like science fiction almost.
Doesn't it? But it's not hypothetical anymore. On July 30th, 2025, just recently, from the Satish Dhawan Space Center in Chennai, the NASA-ISRO Synthetic Aperture Radar satellite NISAR, for short, it headed to orbit.
That's right.
So our mission today, our deep dive, is to cut through the buzz and really unpack why NISAR isn't just, another satellite, why it's potentially a massive game changer for life here on Earth. Okay, let's get into it.
Absolutely. And you used the right word there, game changer. The significance of NISAR, well, it really can't be overstated. This isn't just a small step up. It's a genuine leap forward in how we understand planetary dynamics.
It's a leap forward. How so specifically?
Well, its core capability, this continuous high-resolution monitoring of Earth's surface. And critically, it's designed to see right through clouds, even through complete darkness.
Like the radar aspect.
Exactly. That capability at this scale, with this kind of consistency, we've just never had it before. It's truly set to revolutionize how we interact with and understand our own world.
Revolutionize. I like that. And the mission itself feels revolutionary in terms of collaboration too, doesn't it? NISAR is this historic joint venture, NASA and ISRO working together.
A truly unprecedented partnership at this scale.
Yeah, it's more than just two big space agencies building a satellite together. It feels like a shared vision, a science buddy project, but, with rockets.
That's a good way to put it.
And at the heart of it is this unique dual-band radar system. You've got the L-band, that's NASA's bit, and the S-band from ISR.
And that combination is absolutely key.
That's what gives it the all-seeing power, right?
Right.
But let's bring it down to Earth for a moment. Why should you, listening right now, really care about this huge thing flying overhead?
That's the crucial question.
Because, it sounds like it's about giving us the tools, the data, to be better prepared. Prepared for whatever Mother Nature decides to throw at us, yeah? Disaster prediction, climate change monitoring, even helping farmers.
Precisely right. The practical benefits are immense, and they're incredibly direct for all of us. Think about disaster prediction.
Okay.
We're talking about detecting tiny, subtle ground bulges before a volcano properly erupts, or spotting slight land instability before a landslide hits.
Wow, like an early warning system built in.
Exactly.
Yeah.
Or after an earthquake, mapping building shifts down to a centimeter. That kind of detail is absolutely vital for rescue teams, for rebuilding efforts. It saves lives, and it saves potentially billions in damages.
So it's not just abstract data points.
Not at all. And for climate resilience, NISAR will give us this incredibly detailed, crucial data on ice sheets, how fast they're melting, how they're moving, and forest biomass, tracking deforestation and carbon storage like never before, globally.
And the farming aspect.
Yeah, agricultural monitoring, helping farmers with insights to improve crop yields, use water more efficiently. It's very practical. This level of precision, seeing changes as small as a centimeter over an area half the size of a tennis court, it's just unprecedented.
A centimeter. That's incredible detail from orbit.
It really is. Now, it was a hefty investment, no doubt, around $1.5 billion total, with NASA contributing about $1.2 billion of that.
That's a big number.
It is. But it's an investment that, as we said, could save lives, save money, and fundamentally change our resilience. It's knowledge for global well-being, really.
That point about saving lives and money, the long-term view,
Yeah.
it really frames it differently. It makes me wonder, though, what's maybe a surprising benefit, something we might not immediately think of?
That's a great question. Beyond the obvious, I think the sheer consistency and global coverage, the whole Earth, every 12 days, that opens up possibilities we maybe haven't even fully conceived yet.
Like what?
Well, think about tracking subtle changes in groundwater levels across huge regions, or maybe mapping underground geological stresses. We might start seeing patterns related to earthquakes or resource depletion that are just invisible with our current, more fragmented data. It's like, maybe seeing the butterfly effect of environmental changes in a way we just can't right now.
Seeing those hidden connections.
Yeah.
Fascinating. Okay, but back to basics for a second. How does it do it? How does something, 747 kilometers up, see through thick forests, see in total darkness?
Right, the magic trick. It comes down to its radar, specifically Synthetic Aperture Radar, or SAR.
SAR.
So unlike a regular camera that needs sunlight and gets blocked by clouds, SAR actively sends out its own radio signals, like pulses, down to Earth.
Ah, so it brings its own light source, effectively.
Exactly. It illuminates the Earth with radio waves and then carefully listens for the reflections, the echoes bouncing back. It's like having its own flashlight and super-powered night vision goggles all rolled into one.
Okay, that makes sense. And those two radar bands you mentioned earlier, L-band and S-band, what's the difference? Why two?
Good question. The L-band, that's NASA's main contribution, uses a longer wavelength. Think of it like lower frequency radio waves.
Okay.
And the key thing about longer wavelengths is they can penetrate deeper. They can see through forest canopies, sometimes even into the top layers of the soil itself.
Like an X-ray for the planet.
That's a great analogy. It makes it perfect for monitoring things like changes deep in forests, biomass, but especially for volcanic areas and earthquake zones where you need to see that ground deformation, those subtle shifts happening beneath the surface.
Got it. L-band for depth. So what does ISRO's S-band bring to the party?
The S-band uses a shorter wavelength. It's more sensitive to surface details, finer textures, and smaller changes right at the surface.
So better for things like cities.
Exactly. Perfect for urban analysis, detecting tiny shifts in buildings or infrastructure. Also great for understanding terrain details, mapping floods, tracking changes in land use more precisely.
So you put them together.
And you get this incredible, multi-layered, almost 3D view of how the Earth is changing, measuring those tiny centimeter-scale movements we talked about. It's this dual-band synergy that really makes NISAR unique.
That really is remarkable. And you mentioned it maps the whole globe every 12 days. That sounds like an incredible amount of data to gather so quickly. How does it manage that coverage and detail?
Well, if we connect this to the bigger picture, it's that dual-band radar combined with a very clever scanning technique called SweepSAR. That's how it gets that consistent global map.
SweepSAR.
Yeah. And before it even starts its main mission, there's a crucial 90-day commissioning phase right after launch. Think of it as tuning up the instruments.
Getting everything calibrated.
Precisely. ISRO will be meticulously calibrating the S-band, NASA the L-band, making sure they work together perfectly, like tuning a very complex, very expensive piano in space.
Right. And a huge part of achieving that wide coverage with high resolution is NISAR's massive antenna. It's a 12-meter wide reflector that's nearly 40 feet across.
12 meters? How does that even fit on a rocket?
Well, it doesn't launch like that. It's deployable. It actually unfurls once it's safely in orbit. It's a real piece of engineering artistry unfolds, kind of like a giant metallic flower blooming silently in space.
Wow, a giant flower. That's quite an image.
And it's this huge reflecting surface that allows the SweepSAR technique to scan a really wide swath of the Earth below, grabbing those high-res images as it goes.
Incredible. And speaking of unfolding, this whole project, this satellite, it didn't just appear overnight, did it? You mentioned the investment, but the time. 11 years of work went into this.
Over 11 years, yes. A huge amount of dedicated effort.
That kind of timeline. And it just makes you think about the sheer perseverance involved. It
Yeah.
sounds like a real odyssey to get it from concept to launch pad.
Oh, it absolutely was an odyssey. And a real testament to commitment. Think about the challenges. Just the inherent technical complexity is immense, right? Designing something this advanced.
For sure.
But then layer on top of that the disruption of the COVID-19 pandemic. That hit right when teams needed to be working closely together, integrating components, often across different countries. It created massive logistical and collaborative hurdles.
I can only imagine. Working on hardware that sensitive remotely.
Exactly. And there were tricky engineering problems, too, like managing the heat, the thermal load issues on that giant 40-foot deployable reflector. It needed special reflective coatings, careful reintegration, making sure it would survive the extreme temperatures of space and, crucially, unfold exactly as planned.
Someone apparently joked it was like assembling IKEA furniture in zero gravity.
I can see why they'd say that, though maybe a bit more complex. But it really highlights the incredible dedication needed for these huge science projects, pushing boundaries constantly.
It really makes you appreciate the human side, doesn't it? Behind the amazing tech, there are thousands of people pouring years of their lives into this, facing setbacks.
It raises that important question, what does it take for a global team, scientists, engineers from different backgrounds, different cultures, facing something like a pandemic?
Right.
How do you sustain that focus, that innovation, that collaboration for over a decade on something so complex.
It's mind-boggling.
It truly showcases the power of international cooperation when there's a shared scientific goal. The NASA team and the ISRO team worked incredibly closely, hand in hand, through design, integration, launch prep. It was a genuinely joint effort. It's a powerful model, really.
A model for the future, maybe. That's a really profound point. Okay, so we understand the tech, the how, and the incredible journey to build it. Now, what about the so what? What does all this data NISAR will collect actually mean? How will it be used, not just by scientists in labs, but, out in the world?
Right, the impact, the scope is just staggering. Scientifically, it's going to support this huge range of critical studies. We're talking about monitoring ecosystem disturbances, forest fires, deforestation, recovery, tracking ice sheet collapse with unprecedented detail.
Which is crucial for sea level rise predictions.
Absolutely. Understanding natural hazards, better earthquakes, volcanoes, landslides, looking at sea level rise itself, changes in groundwater. It's going to give us this incredibly detailed, dynamic picture of our planet, constantly updated.
And it's not just for the scientists, right? You hear about commercial interest, too.
Oh, definitely. Industries far beyond pure research are watching NISAR very closely. Think agriculture, optimizing irrigation, predicting yields, insurance assessing risks related to land subsidence or floods, finance, maybe using data for commodity trading, transportation, disaster response. The list goes on.
So Wall Street looking to space for insights.
Kind of. Who knew the key to making money might be orbiting overhead? But seriously, the applications are broad. And really importantly, the data itself is planned to be freely and openly available.
That's huge. So anyone can access it.
That's the goal. The L-band data will come through NASA's Alaska SAR facility, the S-band data through ISRO distribution channels. They even have an early adopters program running already, with over 200 groups, government agencies, private companies, universities, all lined up, figuring out how to use this data as soon as it starts flowing.
That accessibility piece feels really key, making sure this incredible resource isn't locked away.
It absolutely is. And what's fascinating here is that NASA's existing Earth observation data, it's already used by something like 75% of Fortune 100 companies.
Wow, 75%.
Yeah, and over 5 million users globally. So there's already this massive demand, this recognized value. NISAR is going to take that to a whole new level with its detail, its consistency, its global view.
So it builds on a proven need.
Exactly. And looking even further ahead, if we connect this to the bigger picture, the technology behind NISAR, this advanced radar capability, it holds real potential for future planetary missions too.
You mean like missions to other planets?
Potentially, yes. The techniques we're perfecting to map Earth's subsurface movements, to understand its surface dynamics in such detail, that knowledge could directly help us build models for, say, subsurface water ice on the moon, or geological activity, perhaps even past water flows on Mars.
So learning about Earth helps us explore the moon and Mars. That's incredible.
It really brings it full circle. And this NASA-ISRO partnership, as we discussed, it's groundbreaking in itself, isn't it?
The first truly equal partnership, you said.
Yes. This first equal partnership at this scale between NASA and ISRO sets a really powerful precedent. It's a template for future international collaborations, whether it's Earth science, planetary exploration, maybe even human spaceflight down the line. It's a strategic alliance that strengthens those Indo-US space ties for decades to come. It shows that when nations team up for science, well, the sky isn't the limit, it's just the beginning.
Wow, just the beginning. So there you have it, the NASA-ISRO Synthetic Aperture Radar, NISAR. And it really is so much more than just another satellite, isn't it?
Yeah.
It's like a new set of eyes for our planet, born from years over a decade of dedicated global cooperation, incredible perseverance through some major challenges, and this shared goal to understand Earth like never before.
That sums it up perfectly.
And the data it's going to send back, this continuous stream of high-res information, it feels like it could touch almost every part of our lives, how we handle disasters, manage resources like water and forests, how we track climate change, maybe even how we plan trips to other worlds. It's a really exciting time for science. NISAR is definitely one of the big ones. Thanks for joining us on this deep dive into Earth's newest, most powerful, all-seeing eye.
And perhaps, as a final thought, this incredible new ability raises an important question for all of us, doesn't it? As this technology lets us see our planet with such clarity, revealing every subtle change, every vulnerability, how does that change our responsibility, our collective responsibility for how we understand our shared home, how we protect it, how we manage it? Something to think about. I definitely encourage everyone listening to keep an eye out for NISAR's data and discoveries as they start becoming public over the coming months and years. The insights are going to be fascinating, and they'll undoubtedly spark new conversations, hopefully new solutions, and maybe just a deeper appreciation for this amazing planet we live on.